Hello students, how are you? I hope you all are doing great today. My name is Renu Rathi and today we'll be learning our very interesting and a very relatable topic, that is symmetry. Now in this chapter we will learn about introduction, reflection symmetry, what is a rotational symmetry for plane figure and for a challenge as well, operations of rotation through the angles like 90 degree and 180 degree, and then we will learn about the rotational and reflection symmetries examples. Now let's start with our introduction. Now in the introduction part we have told that symmetry, you can see that the resemblance one part of the figure to the other part of the same figure. For example, there is an alphabetical order H. So if we divide H into two parts vertically, we found one part is what? Symmetrical to the other part, students. Now suppose we could fold a picture. If we fold a picture in half such that the left half and the right half match exactly, then such type of picture is called symmetrical picture. And the line which divides the picture into two congruent parts, that is called the line or axis of symmetry. Now we can also see that two halves are what? Mirror images of each other, and if we place a mirror on the folding line, then the image of one side will fall exactly on the other side of the picture, and this folding line is called the mirror line. This is what? This is our folding line. This is the folding line and this is the folding line, and it is also known as a line of symmetry. Now next is our reflection symmetry. Now look at the adjoining figure. The point P dash is what? Is the image of the point of P dash in the line AB. Now if AB is perpendicular bisector of PP dash, then AB is what? The mirror line, and the points of the line on AB are what? Are their own images. Now let's start with our example to understand it better. Example number 1 says that we have to draw the line of symmetry of the following figures. Now this is a line of symmetry and it does not have any line of symmetry. Now example number 2 says that we have to reflect each of the figure given below at the mirror line, and we have to draw the respective image also. So this is our mirror line, this is the other reflection, and this is its other reflection. Now next is our example number 3. Here we have to find the line of symmetry of the following figures with punched holes. So this is its line of symmetry and its vertical line of symmetry. Now in example number 4, we have to complete each of the following figure to be symmetric about the mirror line. So using the concept that image is what? At equal distances as object from the mirror. So we get these our symmetric patterns for the first and the second figure. Now let's start with our exercise 9.1. In the first part, we have to identify the horizontal and vertical line of symmetry in the first one. Very good, it is our horizontal line of symmetry. That's how you have to complete the remaining ones. Now next is our rotational symmetry of plane figures. Now in this we have said that if you can rotate a figure around a center point by fewer than 360 degrees, then the figure appears what? Unchanged, and the figure has what? Rotational symmetry. Now the point around which it rotates is what? It is our center of rotation, and the smallest angle you need to turn, that is our what? Angle of rotation. Now we can easily observe that a certain picture looks identical when it is rotated about a certain point at a certain degree. For example, a square lamina, when rotated by an axis of 90 degree, 180 or 270, retain its shape. That means it will convert into its original shape. This is the original shape, rotated at an angle of 45 degree, then at an angle of 90 degree, same original figure, rotated at an angle of 135 degree, then at 180 degree, again original figure, then rotated at an angle of 225 degree, and then rotated at an angle of 270 degree, then it is our what? Again the original figure. And this point is what? This is our center of rotation. These all are our what? Identical shapes. Now next is, let us take another examples of wheel of 8 spokes. Here are the 8 spokes of the wheel, and it can be easily observed that we have rotated this wheel by what? By 45 degree in each case about its central point, and it regains its original position. Therefore, the square lamina and wheel are said to be what? Turn symmetry or rotational symmetry. Hence, the square lamina shows above has 1/4 turn of symmetry and a 90 degree symmetry, and if the wheel has 1/8 turn, that means it is our what? 45 degree symmetry. Now we can see that rotational symmetry exists when a figure is rotated by less than 360 degree about a central point called what? It is our what? Point of rotation, and we are made to match or coincide with the original figure. Now next is our order of rotational symmetry. An image has rotational symmetry if there is a central point around which the object turns itself into a certain number of degrees, and the object still looks the same if it matches itself a number of times when it is being rotated or complete turn. Now since the triangle shows 3 right will match itself 3 times as it is rotated 3 times, so its rotational symmetry is what? Very good, of order 3. Now similarly, the flower shown at right has rotational symmetry of order 6 since it matches itself 6 times. So also the pizza shown has a rotational symmetry of what? Of order 6 since all the toppings are placed so evenly. Now always remember, if an object matches itself once, it is not considered to have rotational symmetry. If an object has rotational symmetry of order 1, it is not considered to have a rotational symmetry. Order of rotational symmetry is what? That is our 360 degree upon angle of rotation. Now here is rotational symmetry a challenge. Through this activity, using a paper, a compass, a ruler, a pencil, create designs. You have to create these designs of rotational symmetry of different orders and see if you can have such figures of different orders, and you can find different orders or different patterns with these. Now next is our example number 5. Here we have to rotate the following figure about its central point at an angle of 90, 120 and 180 degree. So this is its original position, rotated 90 degree, then 120 degree, and then this is our 180 degree. Since at 180 degree it regains its original position, so it shows rotational symmetry at 180 degree. Now next up is our example number 6. At which angle will a fan has 3, 4 and 5 blades shows rotational symmetry, and also we have to find the order of rotational symmetry. Now in figure 1 we can easily imagine that 3 blade fan rotated about its central point at an angle of what? At an angle of 120 degree, and each of the fan take the position of the next blade, and the fan hole looks similar to the previous position. Now the order of rotational symmetry of this blade having 3 blades, that is 3. Now for a 4 blade has a rotational symmetry at an angle of 90 degree, so the order of rotational degree is 4, and for a 5 blade fan the order of rotational symmetry is 5. Now in example number 7, here we have to find the order of rotational symmetry of the adjoining figure about O. So angle of rotation is 60. By putting it into the formula, order of rotational symmetry is what? 6. Now next up is our exercise 9.2. In the first part, we have to find the order of rotational symmetry in the following figures. So here the rotational degree or symmetry of A is, when we change it into 90 degree it becomes this, then again into the 180 degree, and then into this, and then again. So it has no order of rotational symmetry. That's how you can solve the remaining ones. Here's the project that you have to complete it by yourself, students. Now next step is our operations of rotation through the angles 90 and 180 degree. Now a figure can be rotated about various points, and its point of rotation decides its position as well as its nature. Now suppose a figure shows that the rotational symmetry about a particular point, then the same figure would not show the rotational symmetry about any other point. Now let us understand it better with the help of our example of square lamina. Now case 1 is when it is rotated about its middle point O. It is its original position, rotated at an angle of 90 degree, then 180 degree angle rotation. Then we have observed all the 3 figures are what? They are similar. Now case 2, when the square lamina is rotated about its corner point, say at C. Now original position rotated at 90 and then at 180 degree. Here you can observe that the square lamina does not show the rotational symmetry about point C. Now in example number 8, here we have to rotate the figure given below and about the given point O at an angle of 90 degree and 180 degree. Original position 90 degree angle rotation, then 180 degree angle rotation. Now in example number 9, we have told that which figure will be obtained when the given figure rotate about the point O at an angle of 180 degree. So when we rotate it at an angle of 180 degree, original position 90 degree and then 180 degree, that means we get its opposite triangle. Now next is our rotation and reflection symmetry. These are the figures that shows both rotation as well as reflection symmetry, the triangle, square and these polygons. Now next is as all these figures are regular polygons, so they show both reflection as well as rotational symmetry. Example number 10 says that we have to do two figures which shows only reflection but not rotational symmetry. Here are the two figures, L1 and L are what? These are the line or axis of symmetry and they show only reflection symmetry. In example number 11, we have to do two simple figures which shows both reflection as well as rotation symmetry. So these are L1, L2 and L3, and here are also L1, L2 and L3 shows what? Rotational symmetry at an angle of 120 degree. These are the figures which show only rotational but not reflection symmetry. So here the figure shows both rotational as well as reflection at 90 degree angle. After twisting its lines, this is again shows both but not reflection symmetry at an angle of rotation angle is what? 90 degree. Now next is these are the figures which show only the reflection symmetry but not the rotational symmetry. Let us discuss about the following figures. These are our what? These are our lines of symmetry. So it can be easily seen that each of the above figures fit onto itself in one complete turn, which means it needs to be rotated by what? 360 degree. So the angle of rotation cannot be what? 360 degree, and both the figures show only what? Reflection symmetry. Now next up is our figures which show neither reflection nor rotational symmetry. These are the two examples. In example number 12, which of the following figures show either the reflection or the rotational symmetry or both? So by observing all the options, we have seen that it is obvious that first, second and fourth are what? They are show either rotational or reflection symmetry, but option number third neither show reflection and nor rotational symmetry. Next is our exercise 9.3. In the first part, we have to answer the following questions. Write any alphabet that shows line symmetry only. So the alphabet that shows line symmetry only, that is our what? A. It shows line symmetry. That's how you can complete the remaining ones. Next is our chapter and exercise. Here are our MCQs. We have to take the correct option. In the first part, in the given figure, how many lines of symmetry can be found? Very good, that is C option, no lines of symmetry can be found. That's how you can complete the remaining ones. Next is our mental maths. In the first part, we have asked that does the given figure shows a rotational symmetry? If yes, we have to find the angle of rotation. Yes, it shows a rotational symmetry and you have to find its angle of rotation by yourself. Here is the horse. Here you have to draw a figure which shows the rotational symmetry but not the line symmetry. So our circle is one such example. Next up is our assertion and reasoning that you have to solve it by yourself. Now I hope you have understood the chapter pretty well. Just don't forget to revise this topic again.